What if the universe is trying to talk to us, and we just don't know how to listen? Imagine a moment, late at night, when a faint, mysterious signal from the depths of space reaches Earth, carrying with it a message we can't yet understand. These signals, strange and unexplained, have baffled scientists for decades, sparking debates, theories, and even the hope that we might not be alone in the cosmos. From fleeting bursts of energy to repeating patterns that defy explanation, these cosmic whispers are some of the most intriguing mysteries of our time. In this video, we're diving into 25 of the strangest signals ever detected from deep space. Each one is a puzzle, a clue, and perhaps even a glimpse into the unknown. So, are you ready to explore the eerie, the unexplained, and the downright bizarre? Let's begin. Now, let's turn our attention to one of the most iconic and baffling signals ever detected, the WOW signal. This mysterious burst of radio waves was picked up on August 15, 1977, by the Big Ear radio telescope at Ohio State University. What made this signal so extraordinary was its intensity and its brief yet unmistakable appearance. Lasting just 72 seconds, it was so powerful that the astronomer who discovered it, Jerry Amon, circled the data on the printout and wrote, "Wow." Next to it, a name that has stuck ever since. The signal appeared to originate from the direction of the constellation Sagittarius, near a star system about 120 light-years away. What made it so intriguing was its frequency of 1420 MHz, a range that's significant because it's close to the hydrogen line, a frequency scientists believe extraterrestrial civilizations might use for communication. The WOW signal was strong, narrowband, and seemingly artificial, all characteristics that fueled speculation about its potential extraterrestrial origin. Yet, despite decades of searching, the signal has never been detected again. This has led to a wide range of theories. Some scientists suggest it could have been a natural phenomenon, like a comet or a passing asteroid reflecting radio waves. Others argue that it might have been a one-time event, such as a distant civilization briefly transmitting a message. The lack of a repeat detection has only deepened the mystery, making the WOW signal a cornerstone of the search for extraterrestrial intelligence, or SETI. To this day, the WOW signal remains one of the most compelling pieces of evidence in the ongoing quest to answer the question, are we alone? Its brief appearance and unexplained nature continue to captivate scientists and enthusiasts alike, reminding us that the universe is full of mysteries waiting to be unraveled. And as we move forward, this signal serves as a powerful reminder of how much we still have to learn about the cosmos. Now, as we delve deeper into the mystery of the WOW signal, let's explore the leading theories that attempt to explain its origin. One of the most debated explanations is that the signal could have been caused by a natural phenomenon, such as a comet. In 2017, astronomer Antonio Paris proposed that the signal might have been the result of hydrogen clouds surrounding two comets, 266P Christensen and 335P Gibbs, which were passing through the region at the time. While this theory gained some traction, it was later met with skepticism, as the comets were not in the right position to account for the signal's precise frequency and intensity. This leaves the comet explanation as an intriguing but unproven possibility. On the other hand, the idea that the WOW signal could have been a deliberate transmission from an extraterrestrial civilization continues to captivate imaginations. The signal's narrowband frequency, close to the hydrogen line, aligns with what scientists speculate might be a logical choice for interstellar communication. If an advanced civilization were trying to make contact, they might use this frequency because hydrogen is the most abundant element in the universe, making it a universal meeting point for potential communication. However, the lack of a repeat signal has made it difficult to confirm this theory. leaving it as one of the most tantalizing possibilities in the search for extraterrestrial intelligence. Another angle worth considering is the possibility that the WOW signal was a one-time event, such as a brief burst of energy from a distant star or an interstellar object. Some scientists have suggested that it could have been caused by a rare cosmic event, like a star undergoing a sudden and dramatic change, releasing a burst of radio waves that we happen to catch. While this theory is plausible, it doesn't fully explain why the signal matched the characteristics of an artificial transmission so closely. The ongoing search for signals similar to the WOW signal remains a cornerstone of SETI research. Projects like the Breakthrough Listen Initiative and the Allen Telescope Array continue to scan the skies, hoping to detect another signal with the same unmistakable characteristics. The WOW signal serves as a reminder of how little we know about the universe and the potential for discovering something truly extraordinary. It's a beacon of curiosity, driving scientists and enthusiasts to keep looking, keep questioning, and keep exploring. As we move forward, the WOW signal stands as a testament to the enduring allure of the unknown. Whether it was a natural phenomenon, a fleeting message from an alien civilization, or something else entirely, it challenges us to think beyond what we know and to remain open to the possibilities that lie hidden in the vast expanse of space. And with every new discovery, we inch closer to answering the ultimate question: are we alone? Now, shifting our gaze to another cosmic enigma, let's explore the fascinating story of fast radio burst 121102, or FRB 121102. Discovered in 2016, this signal holds a special place in the annals of astronomy as the first repeating fast radio burst ever detected. Unlike the fleeting, one-time bursts that had been observed before, FRB 121102 defied expectations by repeating its signal multiple times, sparking both excitement and intrigue among scientists. What makes FRB 121102 so remarkable is its repeating pattern. Most fast radio bursts are like cosmic fireworks, bright, brief, and gone in an instant. But this one kept coming back, sending out powerful bursts of radio waves at irregular intervals. This behavior immediately set it apart, raising questions about its origin and the mechanisms behind its repeating nature. Was it a natural phenomenon, or could it be something more deliberate, perhaps even artificial? The source of FRB 121102 was traced to a dwarf galaxy located approximately 3 billion light-years away. This discovery added another layer of mystery, as dwarf galaxies are not typically associated with the kind of extreme astrophysical events that could produce such intense bursts of energy. The fact that the signal originated from such a small, unassuming galaxy only deepened the puzzle, leaving astronomers to wonder what kind of cosmic powerhouse could be responsible. One leading theory suggests that FRB 121102 might be linked to a highly magnetized neutron star known as a magnetar. These incredibly dense stellar remnants are capable of producing immense bursts of energy, and their extreme magnetic fields could explain the repeating nature of the signal. However, even this explanation doesn't fully account for the sheer power and irregular timing of the bursts, leaving room for alternative ideas, including the possibility of advanced extraterrestrial technology. The discovery of FRB 121102 has fundamentally changed how scientists approach the study of fast radio bursts. It has opened up new avenues of research, encouraging astronomers to search for more repeating signals and to develop models that can explain their origins. This signal, with its mysterious repeating pattern, serves as a reminder that the universe is full of surprises, and that even the most unexpected discoveries can reshape our understanding of the cosmos. As we continue to unravel the secrets of FRB 121102, one thing is clear: it represents a tantalizing piece of the cosmic puzzle, challenging us to rethink what we know about the universe and the forces that shape it. Whether it's the product of a magnetar, an alien megastructure, or something entirely unknown, this repeating signal keeps us looking up, wondering what other mysteries are waiting to be uncovered. Now, let's take a closer look at the mystery of repeating fast radio bursts and what they might tell us about the universe. While FRB 121102 remains one of the most famous examples, it's far from the only repeating signal we've detected. These bursts, with their unpredictable patterns and immense energy, continue to challenge our understanding of the cosmos. What could possibly cause such powerful, repeating signals to echo across billions of light years? One of the most widely accepted explanations points to neutron stars, particularly a type known as magnetars. These incredibly dense remnants of exploded stars possess magnetic fields trillions of times stronger than Earth. When these magnetars experience starquakes, massive shifts in their crust, they can release bursts of energy so intense that they're detectable across the universe. This theory fits well with the irregular timing of repeating FRBs, as these starquakes wouldn't follow a predictable schedule. However, even with this explanation, the sheer power of some bursts, like those from FRB 121102, pushes the limits of what we believe magnetars are capable of. Another intriguing possibility is that repeating FRBs could be the result of advanced extraterrestrial technology. While this idea might sound like science fiction, it's a hypothesis that scientists take seriously. For instance, some have speculated that these bursts could be produced by massive energy harvesting structures like hypothetical Dyson spheres or even interstellar communication devices. The repeating nature of the signals could suggest a deliberate attempt to broadcast across vast distances. While there's no concrete evidence to support this theory, it's a fascinating reminder of how little we truly know about the universe and the potential for intelligent life beyond Earth. The discovery of FRB 121102 has had a profound impact on the field of astronomy. Before its detection, fast radio bursts were thought to be one-time events, likely caused by cataclysmic occurrences like the collision of neutron stars or the collapse of black holes. But the repeating nature of FRB 121102 forced scientists to reconsider. It showed that these bursts could originate from stable, long-lasting sources, opening up entirely new avenues of research. Since then, astronomers have identified more repeating FRBs, each adding to the growing body of evidence that these signals are more complex and varied than we initially thought. What's particularly exciting is how FRB 121102 has inspired new technologies and methods for detecting and studying these bursts. Telescopes around the world, like the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, have been designed to scan the skies for FRBs with unprecedented precision. These advancements have not only increased the number of detected bursts, but also allowed scientists to pinpoint their origins with greater accuracy. As a result, we're beginning to piece together a clearer picture of where these signals come from and what they might mean. As we continue to study repeating FRBs, one thing is certain: they are a testament to the universe's ability to surprise us. Whether they're the result of natural phenomena like magnetars or something more extraordinary, these signals challenge us to think beyond the boundaries of our current knowledge. Each new discovery brings us closer to understanding the forces at work in the cosmos, and perhaps one day we'll uncover the true nature of these mysterious bursts. Until then, they remain a captivating reminder of how much we have yet to learn about the vast, enigmatic universe we call home. Now, shifting our focus to another groundbreaking discovery, let's explore the Lorimer Burst, the very first fast radio burst ever detected. This signal, discovered in 2007 by astronomer Duncan Lorimer, was found entirely by accident while analyzing archival data from the Parkes Radio Telescope in Australia. Lasting just a few milliseconds, the Lorimer burst was so powerful that it briefly outshone all other radio sources in the sky. Yet, its fleeting nature left scientists with more questions than answers. Where did it come from, and what could produce such an intense burst of energy? The discovery of the Lorimer Burst marked a turning point in astronomy. Before this, no one had ever observed a signal like it. Its detection opened up an entirely new field of study, one focused on understanding these mysterious, high-energy bursts that seemed to come from the far reaches of the universe. At the time, the idea of fast radio bursts was so novel that some scientists even questioned whether the signal was real or simply an artifact of human-made interference. However, further analysis confirmed its extraterrestrial origin, sparking a wave of excitement and curiosity among astronomers worldwide. One of the biggest challenges in studying the Lorimer Burst and fast radio bursts in general is their incredibly short duration. These signals appear and vanish in the blink of an eye, making them extremely difficult to detect and analyze. Unlike repeating FRBs, which give scientists multiple opportunities to observe them, one-off bursts like the Lorimer Burst are gone before we can even pinpoint their exact location. This fleeting nature has made it nearly impossible to determine their precise origins or the mechanisms behind them. Despite these challenges, the Lorimer Burst has played a crucial role in shaping our understanding of the universe. It proved that these mysterious signals were not just anomalies but a real and significant phenomenon worth investigating. Its discovery paved the way for the development of new technologies and techniques designed to detect and study fast radio bursts more effectively. Telescopes like the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, owe much of their existence to the curiosity sparked by that first fleeting signal. The Lorimer Burst also highlighted the importance of serendipity in scientific discovery. Often, some of the most profound breakthroughs come not from targeted searches but from unexpected findings in unrelated data. This burst, discovered while sifting through old telescope recordings, reminds us that the universe is full of surprises waiting to be uncovered. It's a testament to the power of curiosity and the importance of keeping an open mind when exploring the cosmos. As we continue to study fast radio bursts, the Lorimer Burst remains a cornerstone of this field. It serves as a reminder of how much we still have to learn about the universe and the incredible potential for discovery that lies ahead. Each new burst detected brings us one step closer to unraveling the mysteries of these enigmatic signals, and perhaps one day we'll finally understand what causes them. Until then, the Lorimer Burst stands as a symbol of the endless possibilities that await us in the vast, uncharted reaches of space. Now, turning our attention to another intriguing signal, let's delve into the mystery of SETI-02+14a. Detected in 2003, this radio signal immediately stood out due to its unusual frequency and its apparent origin near the constellation Pisces. What made SETI-02+14a particularly fascinating was its frequency of approximately 1,420 MHz, a range that aligns with the hydrogen line, a frequency often considered a potential marker for extraterrestrial communication. This peculiar characteristic sparked widespread speculation and debate among scientists and enthusiasts alike. The signal was detected by the SETI at Home project, a groundbreaking initiative that harnessed the power of millions of personal computers worldwide to analyze radio telescope data for signs of extraterrestrial intelligence. SETI-02+14a appeared to drift in frequency, a behavior that some argued could be consistent with a signal originating from a planet orbiting a distant star. This tantalizing possibility led to a flurry of excitement, with many wondering if this could finally be the evidence we've been searching for. However, the scientific community remained cautious. While the signal's frequency and drift were intriguing, they were not definitive proof of extraterrestrial origin. Some researchers suggested that SETI-02+14a could be the result of terrestrial interference, such as a satellite or even a malfunctioning piece of equipment. Others pointed out that the signal's drift could be explained by natural phenomena, such as the Doppler effect caused by the motion of a distant celestial body. Despite these alternative explanations, the possibility of SHB 02 plus 14, A being a genuine extraterrestrial signal, could not be entirely ruled out. The debate surrounding SHB 02 plus 14, A highlights the challenges of interpreting signals from deep space. While the idea of detecting a message from an alien civilization is undeniably thrilling, the reality is that such signals are often ambiguous and open to multiple interpretations. This uncertainty underscores the importance of rigorous analysis and the need for repeated observations to confirm the nature of any potential extraterrestrial signal. Unfortunately, SHB 02 plus 14A was never detected again, leaving its true origin shrouded in mystery. What makes SHB 02 plus 14A particularly significant is its role in shaping the ongoing search for extraterrestrial intelligence. It serves as a reminder of the complexities involved in distinguishing between natural and artificial signals, as well as the importance of maintaining a balance between optimism and skepticism in the face of such discoveries. While SHB 02 plus 14A may not have provided definitive answers, it has undoubtedly contributed to our understanding of the challenges and possibilities inherent in the search for life beyond Earth. As we continue to explore the cosmos, signals like SHB 02 plus 14A remind us of the vastness of the universe and the potential for discovery that lies within it. Each mysterious signal brings us one step closer to answering one of humanity's most profound questions. Are we alone in the universe? And while SHB 02 plus 14A may remain an enigma, it stands as a testament to the enduring curiosity and determination that drive our quest to unravel the mysteries of the cosmos. Now, shifting our gaze to another cosmic enigma, let's uncover the mystery of KIC 8,462,852, better known as Tabby's star. Discovered by the Kepler Space Telescope, this star has baffled astronomers with its bizarre and irregular dimming patterns. Unlike most stars, which dim in predictable ways due to orbiting planets, Tabby's star exhibits sudden and dramatic drops in brightness, sometimes by as much as 22%. These unusual fluctuations have sparked a whirlwind of theories, ranging from natural explanations to the tantalizing possibility of alien megastructures. One of the leading natural explanations involves the presence of massive dust clouds or swarms of comets passing in front of the star. These objects could temporarily block its light, causing the observed dimming. However, the sheer scale and irregularity of the dimming events make this explanation difficult to fully reconcile with the data. Some scientists have even proposed that the star might be surrounded by a dense, uneven ring of debris, further complicating the picture. But what truly captures the imagination is the more controversial theory: the idea that the dimming could be caused by a Dyson sphere, a hypothetical megastructure built by an advanced alien civilization. A Dyson sphere is a colossal construct designed to harness the energy of a star, and its presence could explain the star's erratic light patterns. While this theory is undeniably speculative, it has ignited widespread interest and debate, both within the scientific community and among the public. The mystery of Tabby's star has also highlighted the importance of long-term observation. Since its discovery, astronomers have continued to monitor the star, hoping to catch it in the act of dimming again. Each new observation brings with it the potential to uncover more clues, whether they point to natural phenomena or something far more extraordinary. The star's behavior has even inspired citizen scientists to join the effort, analyzing data and contributing to the ongoing search for answers. What makes Tabby's star so compelling is not just the mystery itself, but what it represents. It challenges our understanding of stellar behavior and pushes us to consider possibilities that lie beyond the boundaries of current science. Whether the dimming is caused by dust, comets, or something entirely unknown, Tabby's star serves as a reminder of how much we still have to learn about the universe. As we continue to study this enigmatic star, it invites us to ponder profound questions about the nature of intelligence and the potential for life beyond Earth. Could the dimming of Tabby's star be a sign of an advanced civilization, or is it simply a natural phenomenon we have yet to fully understand? Whatever the answer, the mystery of KIC 8,462,852 remains one of the most intriguing puzzles in modern astronomy, captivating our curiosity and driving us to explore the unknown. Now, turning our attention to another intriguing signal, let's explore the story of HD 164,595. In 2015, a mysterious radio signal was detected coming from this star, located approximately 94 light-years away in the constellation Hercules. The signal, captured by the Ratan 600 radio telescope in Russia, immediately sparked excitement and speculation. What made it so compelling was its strength and the fact that it appeared to originate from a star system that could potentially host habitable planets. For a brief moment, the idea of alien communication seemed tantalizingly close. The signal's frequency of 11 GHz was particularly interesting because it fell within a range that some scientists consider a potential marker for extraterrestrial technology. This led to widespread speculation that the signal could be a deliberate attempt at communication by an advanced civilization. The discovery even prompted a response from the SETI Institute, which quickly trained its telescopes on HD 164,595 to investigate further. The possibility of a breakthrough in the search for extraterrestrial intelligence seemed within reach. However, as scientists delved deeper into the data, the initial excitement began to wane. Closer analysis revealed that the signal's characteristics were inconsistent with what one might expect from an alien transmission. Instead of being a steady, deliberate signal, it appeared to be sporadic and irregular. This raised red flags, as a technologically advanced civilization would likely produce a more consistent and purposeful signal. Additionally, the signal's strength suggested it would require an enormous amount of energy to transmit across such vast distances, making the alien hypothesis even less plausible. The final nail in the coffin came when researchers identified a more likely explanation: human interference. The signal's frequency and pattern closely matched those of satellites and other Earth-based technologies. It was eventually concluded that the signal was most likely caused by a passing satellite or military radar, rather than an extraterrestrial source. While this explanation was disappointing for those hoping for a groundbreaking discovery, it underscored the importance of rigorous analysis in the search for alien signals. The story of HD 164,595 serves as a valuable lesson in the challenges of SETI research. It highlights the need to carefully distinguish between potential extraterrestrial signals and the countless sources of interference that can arise from human activity. While the signal ultimately turned out to be a false alarm, it reminds us of the excitement and curiosity that drive the search for life beyond Earth. Even when the answers aren't what we hope for, each discovery or dismissal brings us one step closer to understanding the universe and our place within it. Now, shifting our focus to another fascinating chapter in the search for extraterrestrial signals, we come to the story of the Ratan 600 telescope and its detection of a strong signal in 2016. This signal, originating from the star HD 164,595, reignited the debate over whether we might be picking up signs of intelligent life beyond Earth. The Ratan 600, a powerful radio telescope located in Russia, captured this intriguing signal, which immediately drew attention due to its unusual strength and the possibility that it could be a deliberate transmission. What made this detection particularly exciting was the context. HD 164,595, a star located about 94 light-years away, had already been the subject of speculation due to its potential to host habitable planets. The idea that a signal from this star system could be a message from an advanced civilization was enough to capture the imagination of scientists and the public alike. The signal's frequency, around 11 GHz, added to the intrigue as it fell within a range that some researchers consider a potential marker for extraterrestrial technology. For a brief moment, it seemed like we might be on the verge of a historic discovery. However, as with many signals in the search for extraterrestrial intelligence, the initial excitement was tempered by further analysis. While the signal was undeniably strong, its characteristics raised questions. Unlike what one might expect from a deliberate alien transmission, the signal appeared to be sporadic and lacked the consistency that would suggest a purposeful attempt at communication. This inconsistency led scientists to question whether the signal could truly be of extraterrestrial origin, or if it might have a more mundane explanation. Adding to the uncertainty was the fact that the signal was detected only once. Despite repeated attempts to observe it again, the Rattan 600 telescope failed to pick up any further transmissions from HD 164595. This lack of repeatability made it difficult to draw definitive conclusions about the signal's origin. Without additional data, scientists were left with more questions than answers, and the signal was ultimately deemed inconclusive. The story of the Rattan 600 signal serves as a reminder of the complexities involved in the search for extraterrestrial intelligence. While the detection sparked excitement and speculation, it also highlighted the challenges of interpreting signals from deep space. Without clear, repeatable evidence, even the most promising signals can remain shrouded in mystery. Yet, each detection, whether conclusive or not, brings us closer to understanding the vast and enigmatic universe we inhabit. As we continue to explore the cosmos, signals like these remind us of the endless possibilities that lie beyond our world. Turning our attention to a more recent and equally intriguing discovery, we arrive at the BLC-1 signal detected in 2020. This signal, which appeared to originate from Proxima Centauri, the closest star system to our own, has sparked significant interest and debate within the scientific community. Proxima Centauri, located just over 4 light-years away, is already a focal point in the search for extraterrestrial life due to the presence of Proxima b, a potentially habitable exoplanet orbiting within its habitable zone. The detection of the BLC-1 signal added another layer of excitement to this ongoing exploration. The BLC-1 signal was identified by the Breakthrough Listen project, an ambitious initiative dedicated to scanning the skies for signs of intelligent life. What made this signal stand out was its narrowband nature, a characteristic often associated with artificial transmissions. Unlike natural cosmic phenomena, which typically produce broad-spectrum signals, narrowband signals are more consistent with what we might expect from a technologically advanced civilization. This feature immediately raised the possibility that BLC-1 could be a deliberate attempt at communication. Adding to the intrigue was the signal's apparent origin from the direction of Proxima Centauri. Given the star's proximity to Earth and the presence of a potentially habitable planet, the idea that this signal could be a message from an alien civilization was both thrilling and plausible. The signal's frequency, around 982 MHz, further fueled speculation, as it falls within a range that is relatively free from terrestrial interference, making it an ideal candidate for interstellar communication. However, as with many signals in the search for extraterrestrial intelligence, the initial excitement was met with cautious skepticism. While the BLC-1 signal exhibited characteristics that aligned with what scientists might expect from an alien transmission, it also presented challenges. For one, the signal was detected only once, and despite extensive follow-up observations, it has not been observed again. This lack of repeatability makes it difficult to confirm its origin or purpose. Additionally, the possibility of terrestrial interference or instrumental artifacts cannot be entirely ruled out, further complicating the analysis. Despite these uncertainties, the BLC-1 signal remains a compelling candidate for further investigation. Its unique characteristics and the tantalizing possibility of a connection to Proxima Centauri have kept it at the forefront of discussions about extraterrestrial communication. Scientists continue to analyze the data, searching for clues that might shed light on its true nature. Whether it turns out to be a groundbreaking discovery or another cosmic mystery, the BLC-1 signal underscores the importance of persistence and open-mindedness in our quest to understand the universe. As we move forward, the story of the BLC-1 signal serves as a reminder of the delicate balance between hope and skepticism in the search for extraterrestrial intelligence. Each detection, no matter how promising, requires rigorous scrutiny and a willingness to explore all possibilities. And while the answers may remain elusive for now, signals like BLC-1 keep us looking to the stars, ever curious about what or who might be out there. Now, let's shift our focus to one of the most fascinating and controversial moments in the search for extraterrestrial intelligence, the so-called response to the Arecibo message. In 1974, scientists at the Arecibo Observatory in Puerto Rico sent a powerful radio signal into space aimed at the star cluster Messier 13, located approximately 25,000 light-years away. This message, encoded with information about humanity, our solar system, and the basics of life on Earth, was a bold attempt to reach out to any potential extraterrestrial civilizations. Decades later, in 2001, a peculiar event reignited interest in this historic transmission. In a field near the Chilbolton Observatory in England, a crop circle appeared that bore an uncanny resemblance to the original Arecibo message. This formation, however, wasn't an exact replica. It contained subtle but significant modifications. The human figure from the original message was replaced with a more alien-like silhouette, and the depiction of our solar system was altered to show a different arrangement of planets. Most intriguingly, the DNA helix in the original message was replaced with a more complex structure, suggesting a possible response from an advanced civilization. The discovery of this crop circle sparked intense debate. Some believed it was a genuine reply to the Arecibo message, a deliberate attempt by an extraterrestrial intelligence to communicate with us. The precision and complexity of the formation seemed to defy explanation, leading many to argue that it couldn't have been created by human hands. Others, however, were quick to point out the flaws in this theory. Crop circles, while often elaborate, have a long history of being human-made hoaxes, and the Chilbolton formation was no exception. Skeptics argued that the modifications to the original message were too convenient, almost as if they were designed to fuel speculation rather than provide meaningful information. Adding to the skepticism was the fact that the Arecibo message was sent to a star cluster so distant that even if an alien civilization had received it, any response would take tens of thousands of years to reach us. The appearance of the crop circle just 27 years after the message was sent seemed implausible, to say the least. Furthermore, no radio signals or other forms of communication accompanied the crop circle, leaving its origin shrouded in mystery. Despite the controversy, the Chilbolton crop circle remains a captivating piece of the puzzle in our search for extraterrestrial intelligence. Whether it was a genuine attempt at communication or an elaborate hoax, it serves as a reminder of humanity's enduring fascination with the idea of contact with other civilizations. It also highlights the challenges of interpreting potential signs of extraterrestrial life, where the line between science and speculation can often blur. As we continue to explore the mysteries of the universe, the story of the Arecibo message and its alleged response invites us to question not only what might be out there, but also how we interpret the signals we receive. It's a tale that blends science, imagination, and the eternal hope that we are not alone in the cosmos. And while the truth behind the Chilbolton crop circle may never be fully known, it remains a compelling chapter in the ongoing quest to understand our place in the universe. Moving forward, let's explore another intriguing mystery that has captivated astronomers and sparked widespread debate: the 234-star anomaly. In 2016, a team of researchers published a study that identified 234 stars exhibiting strange and irregular light patterns. These stars, located within a relatively narrow range of the Milky Way, appeared to flicker in ways that defied conventional explanations. The researchers proposed that these unusual light patterns could be evidence of extraterrestrial megastructures, such as Dyson spheres, hypothetical constructs built by advanced civilizations to harness the energy of their host stars. The idea of Dyson spheres, first proposed by physicist Freeman Dyson in the 1960s, has long fascinated scientists and science fiction enthusiasts alike. These massive structures, if they exist, would partially or completely encircle a star, capturing its energy output for use by an advanced civilization. The irregular dimming observed in the 234 stars seemed to align with this concept, as it suggested the presence of large, artificial objects passing in front of the stars and blocking their light in unpredictable ways. The study quickly gained attention, with many speculating that this could be the first concrete evidence of intelligent life beyond Earth. However, the scientific community responded with caution. Skeptics pointed out that there are numerous natural phenomena that could explain the observed light patterns. For instance, stellar pulsations, dust clouds, or even instrumental errors could produce similar irregularities. The researchers themselves acknowledged that their findings were preliminary and required further investigation to rule out more mundane explanations. One of the key challenges in interpreting these anomalies is the sheer complexity of stellar behavior. Stars are dynamic and often unpredictable, with natural processes that can mimic the effects of artificial structures. Additionally, the study relied on data from the Sloan Digital Sky Survey, which, while extensive, is not specifically designed to detect extraterrestrial megastructures. This raised questions about the reliability of the findings and highlighted the need for more targeted observations using advanced instruments. Despite the skepticism, the 234-star anomaly remains a fascinating topic in the search for extraterrestrial intelligence. It underscores the importance of maintaining an open mind while rigorously testing extraordinary claims. The possibility of discovering alien megastructures is undeniably exciting, but it also requires a careful and methodical approach to avoid jumping to conclusions. As astronomers continue to study these stars, they hope to uncover more definitive answers, whether they point to natural phenomena or something truly extraordinary. This discovery also serves as a reminder of how much we still have to learn about the universe. Even as we develop more sophisticated tools and techniques, the cosmos continues to surprise us with its mysteries. The 234-star anomaly is a testament to the enduring allure of the unknown and the relentless curiosity that drives us to explore the farthest reaches of space. Whether these stars hold the key to extraterrestrial life or simply reveal new aspects of stellar behavior, they represent another step forward in our quest to understand the cosmos and our place within it. Now, let's turn our attention to another cosmic enigma that left astronomers scratching their heads: the Ross 128 signal. Detected in 2017, this mysterious radio signal originated from a red dwarf star located just 11 light-years away from Earth. What made this signal particularly intriguing was its unusual frequency and the fact that it didn't seem to match any known natural or human-made sources. For a brief moment, it sparked hope that we might have stumbled upon a message from an extraterrestrial civilization. The signal was first picked up by the Arecibo Observatory in Puerto Rico during a routine observation of nearby stars. Astronomers noticed that the signal appeared to be periodic, repeating at regular intervals, which immediately raised eyebrows. While periodic signals can sometimes be caused by natural phenomena, the specific characteristics of this one didn't align with anything previously observed. This led to speculation that it could be a deliberate transmission from an intelligent source. However, as with many mysterious signals, the excitement was tempered by the need for careful analysis. One of the leading theories proposed that the signal could have been caused by solar flares from Ross 128 itself. Red dwarf stars are known for their intense stellar activity, including powerful flares that can emit bursts of radio waves. If a particularly strong flare had occurred during the observation, it could have produced the unusual signal. Yet, this explanation didn't fully account for the signal's unique properties, leaving room for doubt. Another possibility was that the signal might have been the result of satellite interference. Earth's orbit is crowded with satellites, and their transmissions can sometimes interfere with astronomical observations. In fact, the Arecibo team initially considered this explanation, as the signal's frequency overlapped with those used by some satellites. However, further investigation revealed that no known satellites were in the right position to have caused the signal at the time of detection. This only deepened the mystery. Despite extensive follow-up observations, the Ross 128 signal has never been detected again, adding to its enigmatic nature. The lack of repetition makes it difficult to study, and without additional data, astronomers are left with more questions than answers. Could it have been a fleeting burst of natural activity, a glitch in the equipment, or something far more extraordinary? The truth remains elusive. What makes the Ross 128 signal so compelling is its reminder of how challenging it can be to distinguish between natural and artificial sources in the vastness of space. Even with our most advanced instruments, the universe often presents us with puzzles that defy easy explanation. As we continue to explore the cosmos, signals like this one serve as both a humbling reminder of our limitations and an exciting glimpse into the possibilities that lie beyond our understanding. Whether it's a natural phenomenon or a sign of intelligent life, the Ross 128 signal remains a tantalizing mystery in our ongoing search for answers. Now, let's shift our gaze to another cosmic puzzle that has intrigued astronomers, the Glimpse C01 signal. This mysterious signal was detected emanating from a dense star cluster known as Glimpse C01, located approximately 10,000 light-years away in the constellation Aquila. What makes this signal stand out is its unusual pattern and the fact that it doesn't neatly fit into any known category of natural phenomena. Could this be a sign of something extraordinary, or is it just another cosmic oddity waiting to be explained? The Glimpse C01 star cluster itself is a fascinating region of space, packed with ancient stars that have been burning for billions of years. When astronomers first detected the signal, they were struck by its irregular bursts of energy, which seemed to defy the predictable rhythms of typical stellar activity. Unlike the steady pulses of a pulsar or the chaotic bursts of a supernova, this signal appeared to flicker in a way that was both erratic and strangely deliberate. This unusual behavior immediately sparked curiosity and raised questions about its origin. One of the biggest challenges in studying the Glimpse C01 signal lies in its distance and the environment from which it originates. The star cluster is located deep within the Milky Way's plane, where dense clouds of gas and dust can obscure observations. This makes it difficult to gather clear data and determine whether the signal is truly coming from within the cluster or if it's being distorted by intervening material. Additionally, the sheer density of stars in the cluster complicates efforts to pinpoint the exact source of the signal, as multiple objects could potentially be responsible. Theories about the signal's origin range from natural explanations to more speculative ideas. Some scientists suggest it could be the result of interactions between stars, such as collisions or close encounters, which can produce bursts of energy. Others have proposed that it might be linked to exotic objects like magnetar's highly magnetic neutron stars capable of emitting intense bursts of radiation. However, none of these explanations fully account for the signal's unique characteristics, leaving room for alternative possibilities. One of the more intriguing and controversial ideas is that the signal could be of artificial origin. Could it be a deliberate transmission from an advanced civilization within the star cluster? While this idea captures the imagination, it's important to approach it with caution. The scientific community emphasizes the need to exhaust all natural explanations before considering more extraordinary possibilities. Still, the glimpse C01 signal serves as a reminder of how little we truly understand about the universe and the potential for discovering something truly groundbreaking. As with many mysterious signals, the glimpse C01 detection highlights the challenges of interpreting data from deep space. The vast distances, complex environments, and limitations of our technology all contribute to the difficulty of unraveling these cosmic enigmas. Yet, it's precisely these challenges that make the search so exciting. Each unexplained signal brings us one step closer to uncovering the secrets of the universe, whether they're natural phenomena or something beyond our current understanding. The glimpse C01 signal remains an open question, a tantalizing clue in our ongoing quest to explore the cosmos. As we continue to refine our instruments and expand our knowledge, who knows what we might discover next? The universe is full of surprises, and signals like this one remind us that there's still so much to learn. Now, let's turn our attention to another cosmic mystery that has captivated both scientists and the public alike: the Kepler star anomalies. These strange light patterns observed by the Kepler Space Telescope have sparked intense debate and speculation about their origins. Could they be evidence of alien megastructures, or are they simply the result of natural phenomena we have yet to fully understand? The Kepler Space Telescope, launched in 2009, was designed to search for exoplanets by monitoring the brightness of distant stars. Over its mission, it observed hundreds of thousands of stars, identifying subtle dips in their light caused by planets passing in front of them. However, among these expected patterns, Kepler also detected something far more unusual: stars with irregular and dramatic dimming that defied conventional explanations. These anomalies were unlike anything seen before, with some stars dimming by as much as 20%, far more than a typical planet could cause. One of the most famous examples is KIC 8462852, often referred to as Tabby's star. This star exhibited erratic and unpredictable dimming patterns, sometimes dropping in brightness for days or even weeks at a time. While initial theories suggested natural causes, such as swarms of comets or massive dust clouds, none of these explanations fully accounted for the star's bizarre behavior. This led some researchers to propose a more radical idea. Could the dimming be caused by a massive artificial structure like a Dyson sphere, built by an advanced civilization to harness the star's energy? The concept of alien megastructures, while speculative, is rooted in the idea that a highly advanced civilization might construct enormous objects to capture and utilize the energy of their host star. A Dyson sphere, for instance, would encircle a star, absorbing its light and converting it into usable energy. While this idea remains firmly in the realm of hypothesis, the Kepler anomalies have reignited interest in the search for such structures, pushing scientists to consider possibilities beyond traditional astrophysics. However, the scientific community remains cautious. Most researchers emphasize the need to explore all natural explanations before jumping to extraordinary conclusions. For example, some studies suggest that the dimming could be caused by uneven dust distributions or the remnants of a shattered planet. Others propose that the anomalies might be the result of stellar activity or interactions with a nearby companion star. Despite these efforts, no single theory has yet provided a definitive answer, leaving the Kepler anomalies as one of the most intriguing puzzles in modern astronomy. The search for answers continues, with new telescopes and advanced instruments joining the effort to unravel these mysteries. Missions like the James Webb Space Telescope and the Transiting Exoplanet Survey Satellite, or TESS, are expected to provide more detailed observations, potentially shedding light on the true nature of these strange signals. As our technology improves, so too does our ability to explore the cosmos and uncover its secrets. The Kepler star anomalies remind us that the universe is full of surprises, challenging our understanding and pushing the boundaries of what we think is possible. Whether these signals are the result of natural phenomena or something more extraordinary, they serve as a testament to the endless curiosity and ingenuity of humanity. As we continue to explore the cosmos, who knows what other mysteries await us? The search for answers is far from over, and each discovery brings us one step closer to understanding our place in the universe. Now, shifting our gaze from the distant stars to something a little closer to home, let's explore the curious case of the Puritan signals. These mysterious radio bursts, first detected by the Parkes radio telescope in Australia, initially sparked excitement among scientists searching for signs of extraterrestrial intelligence. The signals appeared to come from deep space with characteristics that seemed to defy natural explanations. For a brief moment, it seemed like we might have stumbled upon evidence of alien communication. But as it turns out, the truth was far more mundane and surprisingly close to home. The Puritan signals were named after the mythical creature, the Puritan, which was said to cast the shadow of a human despite being a stag. This name was chosen because the signals seemed to mimic the characteristics of extraterrestrial transmissions, yet their true origin remained elusive. For years, researchers puzzled over these bursts, trying to determine whether they were natural phenomena, interference from human technology, or something more extraordinary. The mystery deepened when it was discovered that the signals were only detected during daylight hours, adding another layer of intrigue to their origin. The breakthrough came when scientists realized that the Puritan signals were not coming from the depths of space but from much closer, specifically from microwave ovens in the observatory's break room. It turns out that when a microwave oven was opened mid-cycle, it emitted a burst of radio waves that the telescope picked up as a potential extraterrestrial signal. This revelation was both amusing and enlightening, highlighting the challenges of distinguishing between cosmic phenomena and everyday human activity. The Puritan signals serve as a valuable lesson in the search for extraterrestrial intelligence. They underscore the importance of ruling out terrestrial sources before jumping to conclusions about alien origins. In the field of SETI, or the search for extraterrestrial intelligence, researchers must meticulously filter out interference from satellites, aircraft, and even household appliances to ensure that any potential signals are truly from beyond our planet. This process, while time-consuming, is crucial to maintaining the integrity of the search and avoiding false alarms. While the Puritan signals may not have been the evidence of alien life that some had hoped for, they remain an important chapter in the history of SETI research. They remind us that the universe is full of surprises, and sometimes the answers we seek are closer than we think. As we continue to scan the skies for signs of intelligent life, the lessons learned from the Puritan signals will guide us in distinguishing the extraordinary from the ordinary, ensuring that our search remains focused and credible. The story of the Puritan signals also highlights the ingenuity and persistence of scientists in unraveling cosmic mysteries. What began as a tantalizing hint of extraterrestrial communication turned into a fascinating example of how human technology can mimic the signals we hope to find. It's a reminder that in the quest to understand the universe, we must remain vigilant, curious, and open to all possibilities, even the ones that lead us back to our own kitchens. Now, let's turn our attention to a groundbreaking project that has revolutionized the study of fast radio bursts, the Canadian Hydrogen Intensity Mapping Experiment, or CHIME. This innovative radio telescope, located in British Columbia, Canada, has become a key player in unraveling the mysteries of these fleeting cosmic signals. Unlike traditional telescopes that focus on a single point in the sky, CHIME is designed to scan vast swaths of the heavens, making it uniquely suited to detect the unpredictable and short-lived nature of fast radio bursts. Since its commissioning in 2017, CHIME has detected hundreds of fast radio bursts, including many that repeat. These discoveries have provided astronomers with an unprecedented wealth of data, shedding light on the origins and behavior of these enigmatic signals. One of the most significant contributions of CHIME has been its ability to pinpoint the locations of fast radio bursts with remarkable precision. By tracing these bursts back to their host galaxies, scientists have gained valuable insights into the environments that produce them, from distant star-forming regions to the outskirts of massive galaxies. The sheer volume of fast radio bursts detected by CHIME has also allowed researchers to identify patterns and categorize different types of bursts. Some repeat at regular intervals, while others appear to be one-off events. This diversity suggests that fast radio bursts may have multiple origins, ranging from highly magnetized neutron stars, known as magnetars, to more exotic phenomena like cosmic collisions or even advanced extraterrestrial technology. Each new detection adds another piece to the puzzle, bringing us closer to understanding what causes these powerful bursts of radio waves. Perhaps one of the most exciting aspects of CHIME work is its potential to uncover the true nature of fast radio bursts. By studying their properties, such as their dispersion and polarization, scientists can infer details about the cosmic environments they pass through, including the distribution of matter in the universe. This makes fast radio bursts not just fascinating in their own right, but also valuable tools for probing the large-scale structure of the cosmos. The discoveries made by CHIME have not only expanded our understanding of fast radio bursts, but have also highlighted the importance of innovative technology in advancing astronomy. Its ability to detect and analyze these signals on a large scale has opened new avenues for research, inspiring other projects to adopt similar approaches. As CHIME continues to scan the skies, it promises to uncover even more secrets about these mysterious signals, bringing us closer to answering some of the most profound questions about the universe. With each new fast radio burst detected, we are reminded of how much there is still to learn about the cosmos. CHIME contributions have been instrumental in pushing the boundaries of our knowledge, proving that sometimes the most extraordinary discoveries come from looking at the universe in entirely new ways. As we move forward, the insights gained from CHIME will undoubtedly play a crucial role in shaping the future of astronomy and our quest to understand the mysteries of deep space. Now, shifting our gaze to the southern skies, we arrive at the Parkes Radio Telescope in Australia, a legendary instrument that has played a pivotal role in unraveling the mysteries of deep space. Known affectionately as the Dish, this telescope has been at the forefront of radio astronomy for decades, capturing some of the most intriguing signals ever detected. Among its many discoveries, the Parkes telescope has recorded a series of strange signals that continue to baffle scientists, raising questions about their origins and what they might reveal about the universe. One of the most famous signals detected by Parkes is the so-called Puritan signals. Initially, these bursts of radio waves sparked excitement, as they seemed to share characteristics with fast radio bursts, leading some to speculate about extraterrestrial origins. However, further investigation revealed a surprising twist. These signals were actually caused by microwave ovens in the observatory's break room. While this discovery might seem humorous, it underscores the importance of ruling out terrestrial sources when studying cosmic phenomena. The Puritan signals serve as a reminder of how easily human-made interference can mimic the mysterious signals we seek to understand. But not all signals detected by Parkes have such mundane explanations. Over the years, the telescope has picked up numerous bursts that defy easy categorization. Some of these signals exhibit unusual patterns or frequencies, making it difficult to determine whether they originate from natural astrophysical processes or something more extraordinary. For instance, certain bursts appear to come from regions of the sky with no known astronomical objects, leaving scientists to wonder if they are witnessing a new type of cosmic event or even evidence of advanced extraterrestrial technology. One of the challenges in studying these signals lies in their fleeting nature. Many of the bursts detected by Parkes last only milliseconds, making it difficult to gather enough data to draw definitive conclusions. Additionally, the vast distances these signals travel mean they can be distorted by interstellar gas and dust, further complicating efforts to pinpoint their origins. Despite these obstacles, the Parkes telescope has made significant strides in identifying potential sources, from highly magnetized neutron stars to the chaotic environments surrounding black holes. The Parkes telescope's contributions extend beyond just detecting signals. Its ability to observe large portions of the sky with high sensitivity has made it an invaluable tool for follow-up observations. When other telescopes detect a fast radio burst or a strange signal, Parkes is often called upon to provide additional data, helping to refine our understanding of these enigmatic events. This collaborative approach has been instrumental in advancing our knowledge of the universe's most mysterious phenomena. As we continue to explore the strange signals detected by the Parkes radio telescope, we are reminded of the complexity and wonder of the cosmos. Each new discovery brings us closer to understanding the forces at work in the universe, while also raising new questions that challenge our assumptions. Whether these signals are the result of natural processes or something beyond our current understanding, they serve as a testament to the enduring mystery of deep space and the relentless curiosity that drives us to uncover its secrets. Now, let's journey back to one of the most fascinating moments in the history of astronomy, the discovery of the LGM-1 signal. In 1967, a team of researchers led by Jocelyn Bell Burnell detected a strange, repeating signal that seemed to defy all known explanations. The signal was so regular and precise that it sparked immediate speculation. Could this be the first evidence of extraterrestrial intelligence? The team even jokingly labeled it LGM-1, short for Little Green Men, as they grappled with the possibility of having stumbled upon a message from an alien civilization. But as the team delved deeper into the data, they realized the truth was even more extraordinary. The signal wasn't coming from Little Green Men. It was the first ever detection of a pulsar, a rapidly spinning neutron star that emits beams of radiation like a cosmic lighthouse. This discovery was nothing short of revolutionary. Pulsars provided astronomers with a new tool to study the universe, offering insights into the behavior of matter under extreme conditions, and even helping to confirm Einstein's theory of general relativity. The LGM-1 signal, initially mistaken for an alien transmission, became a cornerstone of modern astrophysics. This story also highlights a crucial lesson in scientific research: the importance of skepticism. While the idea of an alien signal was thrilling, the team didn't let excitement cloud their judgment. Instead, they rigorously tested their findings, ruling out every possible explanation before arriving at the correct conclusion. This disciplined approach is what separates science from speculation, ensuring that discoveries are grounded in evidence rather than wishful thinking. The LGM-1 signal reminds us that the universe is full of surprises, but it's our commitment to careful investigation that allows us to uncover its true nature. The discovery of pulsars didn't just solve a mystery, it opened up entirely new avenues of exploration. Today, pulsars are used to study everything from the structure of the Milky Way to the ripples in space-time known as gravitational waves. They've become indispensable tools in our quest to understand the cosmos, all thanks to a signal that was once thought to be a message from beyond the stars. As we continue to search for strange signals from deep space, the story of LGM-1 serves as both an inspiration and a cautionary tale, reminding us to approach the unknown with both curiosity and rigor. And speaking of strange signals, our next discovery takes us to an interstellar visitor that sparked its own share of debates, a mysterious object that seemed to defy all expectations. But more on that soon. Now, let's turn our attention to one of the most enigmatic visitors from beyond our solar system, Oumuamua. In 2017, astronomers detected an object hurtling through space at incredible speeds, and it didn't take long for them to realize this was no ordinary asteroid or comet. Oumuamua, which means scout or messenger in Hawaiian, was the first known interstellar object to pass through our solar system, and its peculiar characteristics immediately sparked intense debate. What made Oumuamua so unusual? For starters, its shape was unlike anything we've ever seen. Most asteroids and comets are roughly spherical or irregular, but Oumuamua was elongated, almost cigar-shaped, with estimates suggesting it was up to 10 times longer than it was wide. This bizarre form alone was enough to raise eyebrows, but there was more. As Oumuamua traveled through our solar system, it exhibited unexpected acceleration, speeding up in a way that couldn't be explained by gravity alone. Comets often accelerate due to outgassing the release of gas and dust as they heat up, but Oumuamua showed no signs of a coma or tail, the typical hallmarks of such activity. These anomalies led some scientists to propose a startling possibility. Could Oumuamua be an artificial object, perhaps even an alien probe? The idea gained traction, with some researchers suggesting that its unusual shape and acceleration might be evidence of advanced technology. Could it be a solar sail propelled by the pressure of sunlight, or even a derelict spacecraft drifting through the cosmos? While these theories captured the public's imagination, others urged caution, pointing out that natural explanations, though still unknown, couldn't be ruled out. The debate over Oumuamua's true nature continues to this day. Some argue that it could be a fragment of a larger object shattered by a cosmic collision, while others propose it might be a new type of interstellar body we've never encountered before. What's clear is that Oumuamua has challenged our understanding of the universe, forcing us to reconsider what might be lurking in the vast expanse between stars. Whether it's a natural oddity or something more, this mysterious visitor has left an indelible mark on the field of astronomy. As we ponder the mysteries of Oumuamua, our journey through the cosmos brings us to another intriguing discovery, a star whose strange dimming patterns have puzzled scientists for years. But more on that soon. Now, shifting our gaze back to a star that has captivated astronomers for years, we revisit Tabby's star, also known as KIC 8462852. This star first made headlines when the Kepler Space Telescope observed its bizarre and irregular dimming patterns, which defied conventional explanations. Unlike typical stars whose brightness dips are caused by orbiting planets, Tabby's star exhibited dramatic and unpredictable drops in light, sometimes by as much as 22%. These fluctuations sparked a wave of speculation, with some suggesting the dimming could be caused by alien megastructures like a Dyson sphere designed to harness the star's energy. Over the years, researchers have proposed numerous theories to explain this cosmic puzzle. One leading hypothesis suggests that the dimming could be caused by massive clouds of dust orbiting the star. These clouds, possibly remnants of a planetary collision or a swarm of comets, could periodically block the star's light in irregular patterns. Another theory points to the star's own internal activity, such as magnetic storms or stellar pulsations, as the source of the dimming. Yet, despite these explanations, no single theory has fully accounted for all the observed phenomena. Recent studies have brought us closer to unraveling the mystery. Observations from ground-based telescopes and space observatories have provided more detailed data, revealing that the dimming events are not uniform. Instead, they vary in depth, duration, and timing, adding another layer of complexity to the puzzle. Some researchers now believe that a combination of factors, dust, stellar activity, and perhaps even orbiting debris, could be responsible for the star's strange behavior. While the idea of alien megastructures remains a tantalizing possibility, the scientific community continues to lean toward natural explanations, emphasizing the need for further observation and analysis. The ongoing research into Tabby's star highlights the challenges of studying such enigmatic objects. Each new observation brings us closer to understanding, but also raises new questions. Could this star be a unique cosmic anomaly, or does it represent a new class of stellar behavior we've yet to fully comprehend? As astronomers continue to monitor Tabby's star, one thing is certain: this cosmic mystery is far from solved, and its secrets may hold the key to unlocking new insights into the universe. With the intrigue of Tabby's star still lingering, our exploration of strange signals from deep space takes us to another fascinating discovery: a repeating fast radio burst with a mysterious 16-day cycle. But more on that next. Now, let's turn our attention to a signal that has left astronomers both baffled and fascinated: FRB 180916. This fast radio burst, first detected in 2018, stands out not just for its repeating nature, but for its remarkably consistent 16-day cycle. Unlike most fast radio bursts, which appear randomly and vanish without a trace, FRB 180916 follows a predictable pattern, emitting bursts for about 4 days before falling silent for the next 12. This rhythmic behavior has sparked intense curiosity, as it challenges our understanding of what could possibly produce such precise and repeating signals from deep space. Theories about the source of FRB 180916 range from the exotic to the more grounded. One leading hypothesis suggests that the bursts could originate from a highly magnetized neutron star, known as a magnetar, orbiting another object such as a black hole or a massive star. In this scenario, the 16-day cycle could be tied to the orbital period of the magnetar, with bursts occurring when the star's magnetic field interacts with its companion in specific ways. Another intriguing possibility is that the signal comes from a binary system where one object periodically eclipses the other, temporarily blocking the burst and creating the observed pattern. Some researchers have even speculated that the signal could be linked to advanced extraterrestrial technology, though this remains a fringe idea. The regularity of the bursts has led to comparisons with artificial beacons or communication systems, but most scientists emphasize the need for natural explanations before considering such extraordinary claims. What makes FRB 180916 particularly compelling is that it offers a rare opportunity to study a repeating fast radio burst with a known cycle, allowing astronomers to predict and observe its behavior over time. As observations continue, the mystery of FRB 180916 deepens. Each new burst provides more data, yet the true nature of its source remains elusive. Could this signal be a cosmic lighthouse pulsing with the rhythm of an unseen celestial dance? Or is it a clue to a new class of astrophysical phenomena we've yet to fully understand? Whatever the answer, FRB 180916 reminds us that the universe is full of surprises, and every signal we detect brings us one step closer to unraveling its secrets. With the enigma of FRB 180916 still echoing in our minds, we now turn to another groundbreaking effort in the search for extraterrestrial signals, the SETI at Home project, where everyday citizens have joined the hunt for cosmic mysteries. But more on that next. Now, let's shift our focus to a project that has brought the search for extraterrestrial intelligence into the homes of millions, the SETI at Home initiative. This groundbreaking project, launched in the late 1990s, harnessed the power of everyday computers around the world to analyze vast amounts of radio telescope data for potential signs of alien life. By distributing small chunks of data to volunteers, SETI at Home created one of the largest distributed computing networks in history, allowing ordinary people to contribute to one of humanity's most profound questions: are we alone in the universe? Over its 2 decades of operation, SETI at home has sifted through countless signals, identifying several that have sparked excitement and intrigue. One of the most notable was a signal detected in 2003, known as SHB02+14a. This signal, originating from a region near the constellation Pisces, stood out due to its unusual frequency and the way it seemed to drift, characteristics that didn't align with known natural sources. While it was later deemed inconclusive, it remains one of the most tantalizing candidates ever analyzed by the project. Another intriguing discovery came in 2015, when a volunteer's computer flagged a signal that appeared to originate from the star HD 164595. This detection briefly reignited hopes of finding extraterrestrial intelligence, though further analysis suggested it was likely caused by human-made interference. Despite this, the signal highlighted the power of SETI at home in identifying potential candidates that might otherwise have gone unnoticed. What makes SETI at home truly remarkable is its ability to democratize science. By involving the public, it not only accelerated the search for extraterrestrial signals, but also inspired a new generation of space enthusiasts. The project's success lies in its ability to turn the vast, overwhelming task of analyzing cosmic data into something accessible and engaging for anyone with a computer and an internet connection. As we reflect on the contributions of SETI at home, it's clear that this initiative has reshaped how we approach the search for extraterrestrial intelligence. While no definitive proof of alien life has been found, the project has demonstrated the incredible potential of collective effort and the enduring human desire to explore the unknown. With the lessons learned from SETI at home, we now turn to another ambitious endeavor in the search for cosmic signals, the Breakthrough Listen initiative, which promises to take the hunt for extraterrestrial intelligence to new heights. But more on that next. Building on the legacy of SETI at home, the Breakthrough Listen initiative represents the next leap forward in humanity's quest to uncover signs of extraterrestrial intelligence. Launched in 2016, this ambitious project is one of the most comprehensive efforts ever undertaken to scan the cosmos for signals that could hint at the presence of alien civilizations. Funded by billionaire Yuri Milner and supported by luminaries like Stephen Hawking, Breakthrough Listen combines cutting-edge technology with an unprecedented scale of observation, aiming to answer one of science's greatest questions: are we alone? At the heart of the initiative is its use of some of the world's most powerful telescopes, including the Green Bank Telescope in West Virginia, the Parkes Observatory in Australia, and the Automated Planet Finder in California. These instruments are equipped with advanced receivers capable of detecting even the faintest signals across a wide range of frequencies. What sets Breakthrough Listen apart is its ability to process vast amounts of data in real time, thanks to state-of-the-art algorithms and machine learning techniques. This allows the project to sift through billions of radio channels simultaneously, searching for patterns that might indicate intelligent life. One of the most exciting aspects of Breakthrough Listen is its scope. The initiative is scanning not just nearby stars but entire galaxies, covering a volume of space 1,000 times greater than previous SETI efforts. It's also targeting a broader range of signal types, including laser pulses that could be used for interstellar communication. This expanded approach increases the chances of detecting something truly extraordinary, whether it's a deliberate message from an alien civilization or an unintentional signal leaking from their technology. While Breakthrough Listen has yet to find definitive evidence of extraterrestrial intelligence, it has already made significant strides. In 2017, the project detected a series of fast radio bursts from a distant galaxy, adding to the growing mystery of these enigmatic signals. More recently, it has focused on analyzing data from nearby stars like Proxima Centauri, where the BLC-1 signal was detected in 2020. Though these findings remain inconclusive, they underscore the project's potential to uncover groundbreaking discoveries. What makes Breakthrough Listen truly transformative is its commitment to open science. All data collected by the initiative is made publicly available, allowing researchers and enthusiasts around the world to contribute to the search. This collaborative approach not only accelerates progress, but also fosters a global sense of curiosity and wonder about our place in the universe. As we look to the future, Breakthrough Listen continues to push the boundaries of what's possible in the search for extraterrestrial intelligence. With its advanced technology, vast scope, and collaborative spirit, it stands as a beacon of hope in our ongoing exploration of the cosmos. And as we ponder the mysteries of the universe, we're reminded that the search for answers is as much about the journey as it is about the destination. Next, we'll explore how the Fermi paradox adds another layer of intrigue to the strange signals we've encountered so far. Now, let's turn our attention to one of the most perplexing questions in the search for extraterrestrial intelligence, the Fermi paradox. Named after physicist Enrico Fermi, who famously asked, "Where is everyone?" This paradox highlights the contradiction between the high probability of alien civilizations existing in the universe and the complete lack of evidence for their existence. Despite the countless strange signals we've detected from deep space, none have provided definitive proof of extraterrestrial life. So, what's going on? One possible explanation lies in the sheer vastness of the universe. Even with advanced technology, our ability to detect signals is limited by distance and time. A signal sent from a distant star system might take thousands or even millions of years to reach us, and by the time it does, the civilization that sent it could have long since vanished. Additionally, the signals we detect might be too faint or too brief for us to interpret correctly. Imagine trying to hear a whisper in a crowded stadium. It's no wonder we might miss something. Another factor to consider is the nature of the signals themselves. Many of the strange signals we've encountered, like fast radio bursts or the wow signal, are fleeting and difficult to study. They appear for mere moments and then vanish, leaving scientists with more questions than answers. Even when we detect repeating signals like FRB 121102, their origins remain shrouded in mystery. Could these be natural phenomena, or are they deliberate attempts at communication? Without more data, it's impossible to say for sure. The Fermi paradox also raises the possibility that advanced civilizations might communicate in ways we can't yet detect or understand. For example, they might use technologies far beyond our current comprehension, such as quantum communication or gravitational waves. Or perhaps they've chosen to remain silent, avoiding contact with less advanced species like us. This idea, known as the zoo hypothesis, suggests that we might be intentionally isolated, observed from a distance like animals in a cosmic zoo. Then there's the sobering possibility that intelligent life is incredibly rare, or that it doesn't last long. Civilizations might rise and fall before they ever develop the technology to communicate across the stars, or they might self-destruct through war, environmental collapse, or other catastrophes. If this is the case, the silence we hear might not just be a lack of signals, it might be a warning. Despite these challenges, the search for extraterrestrial intelligence continues to inspire hope and curiosity. Projects like Breakthrough Listen and SETI are pushing the boundaries of what we know, scanning the skies for signals that could one day provide the answers we seek. And while the Fermi paradox reminds us of the enormity of the task, it also underscores the importance of persistence. After all, the universe is vast and we've only just begun to explore it. As we reflect on the strange signals we've encountered so far, the Fermi paradox serves as a humbling reminder of how much we still have to learn. It challenges us to think creatively, to question our assumptions, and to keep searching for answers. And who knows, the next signal we detect might just be the one that changes everything. Up next, we'll explore how artificial intelligence is revolutionizing the way we search for these mysterious signals. opening up new possibilities in our quest to uncover the truth. Now, as we venture into the next frontier of our cosmic exploration, let's take a closer look at how artificial intelligence is transforming the way we search for extraterrestrial signals. In a universe filled with endless data, the challenge isn't just detecting signals, it's making sense of them. This is where artificial intelligence steps in, offering a powerful tool to sift through the noise and uncover the whispers of the cosmos. Artificial intelligence excels at processing vast amounts of information at incredible speeds, something that would take humans lifetimes to accomplish. For example, projects like Breakthrough Listen and SETI are now using machine learning algorithms to analyze radio signals from distant stars. These algorithms can identify patterns and anomalies that might otherwise go unnoticed, helping scientists prioritize which signals to investigate further. Imagine trying to find a needle in a haystack, but instead of using your hands, you have a magnet that can instantly pull out anything metallic. That's the kind of advantage artificial intelligence brings to the table. One of the most exciting aspects of artificial intelligence is its ability to learn and adapt. Unlike traditional methods which rely on pre-programmed rules, artificial intelligence systems can improve over time as they process more data. This means they can become better at distinguishing between natural phenomena like pulsars or cosmic interference and potential signs of intelligent life. For instance, artificial intelligence has already been used to re-examine old data sets, uncovering signals that were initially overlooked. It's like having a second pair of eyes, or rather, a supercharged brain that never gets tired. But artificial intelligence isn't just about speed and efficiency. It's also about creativity. By analyzing data in ways humans might not think of, artificial intelligence can uncover connections and patterns that could lead to groundbreaking discoveries. For example, it might detect subtle variations in a signal's frequency or timing that hint at a deliberate attempt at communication. These insights could be the key to unlocking the mysteries of signals like fast radio bursts or the wow signal, bringing us closer to answering the question of whether we're alone in the universe. Of course, artificial intelligence isn't without its challenges. One concern is the risk of false positive signals that appear promising but turn out to be natural or even man-made. To address this, scientists are developing more sophisticated algorithms that can cross-check results and reduce errors. It's a delicate balance, but one that holds immense potential for the future of SETI research. As we look ahead, the role of artificial intelligence in signal detection is only set to grow. With advancements in computing power and machine learning, we're entering a new era of exploration where the boundaries of what we can discover are constantly expanding. Artificial intelligence isn't just a tool, it's a partner in our quest to understand the universe and our place within it. And as we continue to refine these technologies, who knows what secrets they might help us uncover. Up next, we'll explore the future of SETI research and the exciting possibilities that lie ahead in our search for answers. As we turn our gaze toward the horizon of cosmic discovery, the future of SETI research shines with promise and potential. The search for extraterrestrial intelligence is entering a new era, driven by cutting-edge technologies and ambitious projects that could redefine our understanding of the universe. One of the most exciting developments on the horizon is the construction of next-generation telescopes like the Square Kilometre Array or SCAR. This massive radio telescope, set to be the largest of its kind, will scan the skies with unprecedented sensitivity, capable of detecting faint signals from the farthest reaches of space. Imagine a tool so powerful it could pick up whispers from galaxies billions of light years away. This is the kind of leap forward we're talking about. But it's not just about building bigger telescopes. Advances in data processing and artificial intelligence are set to play a pivotal role in the future of SETI. As we've already seen, artificial intelligence is transforming how we analyze signals, but the next wave of innovation will take this even further. Machine learning algorithms are being designed to handle the sheer volume of data these new telescopes will produce, identifying patterns and anomalies with incredible precision. This means we'll be able to sift through cosmic noise more efficiently than ever before, increasing our chances of finding something truly extraordinary. Another exciting frontier is the integration of optical and infrared SETI. While traditional SETI focuses on radio waves, these new approaches look for laser pulses or other forms of light-based communication. Projects like the Laser SETI initiative are already underway, using advanced cameras to scan the night sky for brief flashes of light that could indicate an extraterrestrial signal. This multi-wavelength approach broadens the scope of our search, opening up new possibilities for discovery. Collaboration is also key to the future of SETI. International partnerships are bringing together scientists, engineers, and researchers from around the globe to pool resources and expertise. Initiatives like the Breakthrough Listen project are leading the charge, but they're not alone. Universities, private organizations, and even citizen scientists are contributing to the effort, creating a global network of minds dedicated to solving one of humanity's greatest mysteries. This collective effort ensures that no stone is left unturned in our quest to find answers. Looking further ahead, the potential for space-based SETI missions is another area of exploration. Imagine telescopes orbiting Earth or even stationed on the Moon, free from the interference of our atmosphere. These platforms could provide a clearer, more detailed view of the cosmos, enhancing our ability to detect and analyze signals. While these missions are still in the conceptual stage, they represent the kind of bold thinking that could push SETI research into uncharted territory. The future of SETI is not just about technology, it's about curiosity, collaboration, and the relentless pursuit of knowledge. As we continue to refine our tools and expand our search, we're not just looking for signals, we're seeking to understand our place in the universe. And with each new discovery, whether it's a faint radio whisper or a burst of light from a distant star, we move one step closer to answering the question that has captivated humanity for centuries: are we alone? The journey ahead is filled with possibilities, and the next chapter of SETI research promises to be as thrilling as the mysteries it seeks to unravel. As we bring our journey through these 25 strange signals from deep space to a close, it's impossible not to feel a sense of awe at the vastness and mystery of the cosmos. From the enigmatic WOW signal to the repeating patterns of FRB 121102, each signal has offered us a tantalizing glimpse into the unknown. These discoveries remind us that the universe is far more complex and unpredictable than we often imagine, filled with phenomena that challenge our understanding and ignite our curiosity. What makes these signals so significant is not just their mystery, but what they represent in our ongoing quest to understand the universe. They are reminders that we are still in the early stages of exploring the cosmos, and that every detection, every anomaly, brings us closer to answering some of humanity's most profound questions. Are we alone? Is there intelligence beyond our planet? These signals don't provide definitive answers, but they keep the conversation alive, pushing us to look deeper, think bigger, and dream beyond the limits of our current knowledge. The possibility of extraterrestrial life remains one of the most captivating ideas in science, and these strange signals are a testament to the fact that the search is far from over. Whether they originate from natural cosmic phenomena or something more extraordinary, each signal adds a piece to the puzzle, encouraging us to keep exploring, keep questioning, and keep wondering. The universe is vast, and its secrets are waiting to be uncovered. So, as we wrap up this exploration of strange signals from deep space, I want to leave you with a thought. The mysteries of the cosmos are not just for scientists or astronomers, they belong to all of us. Every time we look up at the night sky, we're reminded of how much there is to discover and how much we still have to learn. Stay curious, stay inspired, and never stop asking questions. If you enjoyed this journey through the strange and unexplained, don't forget to hit the like button, share your thoughts in the comments, and subscribe for more deep dives into the mysteries of space. The universe is full of wonders, and together we can keep exploring its secrets. Until next time, keep looking up. You never know what you might find.